proposed approach and our preliminary experiment and results before completing and giving future direction we head to. So firstly, we chose to work on national business matching because many times it is cited as a critical point for global prosperity. So many times the UN says partnership for the goals, or like for the sustainable development goals, or for the millennium goal, the global partnership for development. But actually the truth is, finding an appropriate counterpart in business is really tough, mainly because of information overload. Too much things to check before finding an appropriate business partner to work with. So most of the time, business people are limited to word of mouth to expand their network. That makes it even harder for new business to expand and to grow the opportunities. So to have a clear picture of what kind of problem we're trying to solve is, let's say we have a manufacturing company in Japan that is using a freight company using ABC, and they want to expand in somewhere in Ivory Coast, which is somewhere in West Africa, but going there, they would like to have the same freight service. So the business person might ask itself, like, which company in this country is similar to ABC I'm using in Japan? And then we would like to build a system that can recommend you. You should maybe probably have a look at XYZ companies that might be a good choice to partner with. So now the technology we have is mostly traditional keyword-based search engine. So in this case, we don't really think traditional search engines might help, because the previous question, like, if you just enter in a search engine, you will have nothing related to what you are expecting to get. So recommendation system which require little to no prior knowledge from the user might be a good approach. But the limit here is how to define an ontology or a taxonomy for set dynamic areas such as business. Like, business can change their focus at any time or close, and so on. So that's why we thought this program might be interesting. So far we have some proposed work in business-to-business partnership. In 2005, but this one, they tried to build an ontology for each type of e-commerce business. So it looks very tedious and kind of not very practical in the real world. On the other hand, we have some other new approach for recommending mechanism. They use word vector, like just using based on user comments or some text, but they apply to problem we already have in solution. So they try to improve existing recommending mechanisms for movies or other products. But actually, the unsupervised learning property of word vector might help having a breakthrough in areas such as business-to-business recommendation. So that's why our proposed approach is to build a recommending mechanism to support business partnership, and we plan to use text related to businesses and train word vector models. And train word vector models, and then we'll just run some experiment to see if it makes sense to use word vector for business-to-business recommendation. So basically, the question we ask ourselves is word embedding suitable as a recommended system baseline for business matching? So here is the system we're aiming at. Like, now we're looking at this area where we build a crawler that will collect business news, and then we will run word vector algorithm to train word vector model, and then maybe users will answer queries like the previous one using natural language that will be converted using syntactic parser, and then we have the recommended system using the vector we obtain after training the model. So for our first experiments, we just use the standard data sets, which is Wikipedia. We train the English, French, and Japanese Wikipedia, and then we run some maybe question business people might have to see if it may help us, the web vector can help us building a business-to-business machine recommender system. So the first question we look at is this one, like, are there any companies in Japan like Samsung is in Korea? So like we might break down this question to what is for Japan that Samsung is for Korea. And in terms of vector calculation, it will be like the vector representing the word Japan plus the vector representing the word Samsung minus the vector representing the word Korea. So for those who are not really familiar with word vector, it's just a statistical techniques to predict the next word in a text. So it converts the text in vectors in a vector space. So here, when we look at the results, in either case of different Wikipedia covers, we all have Japanese electronic companies, which is pretty interesting for what we're trying to do. So this is just the logo of the companies for the English Wikipedia. And another question we ask is that which company should be associated to GM as General Motors to create a similar relationship between Renault and Nissan, because we know that Renault and Nissan they have a very fruitful partnership. So when we broke down this question into vector operation and run it in our model, this time we kind of get many noisy words like motors, powertrain, which are not companies, but here if we look at the Wikipedia, English Wikipedia, we see that there is Isuzu. So for when we were working on this research, like I chose the kind just because I know maybe something about it, but actually this question uncovers something I was not aware of. That like actually General Motors and Isuzu they had a partnership in the past. So I think this also encourages going forward in our research. Another experiment we run is to try to plot the relationship between car companies and the originating countries. So here we see just the line represented the vector relation between a car manufacturer and these original countries. Here it is like the more parallel the lines are, the more likely we're able to find a good similarity relation between either the company or the car manufacturer. But as we can see, we can find in some case we have very good representation. For example, Hyundai in Germany. But most of the time, especially in the French and the Japanese Wikipedia, the lines are not really parallel. So maybe it's due to the fact that in French and Japanese Wikipedia we have less articles, and also because of the noisy words. And lastly, we had this other experiment where we plot companies according to the industry on the models we built with word vector, and then it automatically clusters the companies. So these are and that's where we choose, and we try to pick up the most influencing companies. So here, especially for motor vehicle and information technology, they are clearly clustered in all the different purposes. But for retail, oil and gas, they kind of mixed, because actually you can say that retail and distributing oil and gas are not really far. So this brings us to a conclusion that we run very preliminary experiment to just see if actually this, what we're thinking about makes sense. So most of the results kind of encourage us to go into that direction, and then, but then we need to improve maybe our approach by first using specific corpus, because Wikipedia is too generic and talking about everything. So that's why we get maybe noisy words. So we're building a crawler to target specific business news websites, and then also train multi-language models. So not training different models in different languages, but training all of them in the same vector space. And another thing is that to add a new entity recognition layer, so that we might very drastically reduce the noise from words. So that's it. Thank you. Any questions?
Any questions? All right.
Thank you for your presentation. It was really interesting to see this kind of application. My question is, I have actually two questions. Did you use an already trained embedding layer? Because you said you brought some text from news websites, from business news websites. So did you use those texts to train your embedding layers, or did you use text from Wikipedia? This is my first question. And the second one is, how did you evaluate your clustering of vectors that you showed in the second video?
Okay, thank you very much. So first, we are growing business news website, but actually it's kind of tough because not all of them, the product to run on them. So to go on with this experiment, we use Wikipedia. We didn't use the text we got from the business news because we got very few for now. So we use Wikipedia for this experiment. And then here, to evaluate the clustering, we don't have like a particular model for evaluate. It's just like visual evaluation. But later, we plan to build maybe an evaluation to see how closely or how related they are. But for now, it's just visual evaluation.
Thank you.
Any other question? We have run out of time because we thorough presenters on this one. Any other questions? And let me ask a question. You gave me an example to make a decision whether Samsung is Korean company or American company. It's not easy to make a decision. I mean, what perspective we are talking about? Probably more than 51% shareholders are American. Would you consider as an American company or Korean company? What kind of knowledge? I mean, how will you justify? I mean, is Samsung is Korean company or what is it? It depends on what kind of criteria to make decision to come to
maybe today we have some companies that were born in some countries, but actually most shareholders are in another country. So we didn't look at that, but I think it's a really solid point. So I will note that and maybe think about it. And second question was.
Where did you get the information from?
Yes. Okay, sorry. Actually, we get it really easily because building and creating the web is not really easy if you want an efficient product. So actually, Wikipedia they offer downloadable corpus. So it's downloadable entire Wikipedia. So we download it and we just remove all the markup and we structure it in such a way that we can write the mathematical model. So it's unsupervised, so we just specify the parameters according to what we want to run. We just let the algorithm run it and then we run vector calculation. So we don't have to structure something in particular. That's why we plan to use what we call business to business match.
So you extract the sentences and you make it structured to reason it, or you just get the whole vectors you create from unstructured information.
Excuse me.
Which one is it? Oh, you haven't told me.
Yes, I have.
Oh,
But I don't think I have.
okay. Maybe I thought you had. Okay. Do you understand what I'm talking
Yes, yes. So actually, we use instead of sentences, we use words only. Words, and when we get the Wikipedia corpus, like we could process it, in such a way that we might find